Welcome back, chemists. Let's talk about salt solutions. All right, we've seen what happens with weak acids. We've seen what happens with weak bases. But what happens if there's ions that are put together and then put into water? What is going to happen to the overall water? So we saw that cations would turn the solution acidic. We saw that anions would turn the solution basic. What is going to happen when we combine the effects? And so any ionic solid containing a cation other than a proton and an anion other than a hydroxide. So by definition, if you had a molecular compound that reacted with water, that would be called an acid. That wouldn't be this issue. And if you had an ionic solid that contained either the hydroxide or the oxide, well, that would be by definition a base. So that's not this topic. So we are talking about anything other than the protons or the hydroxides. And then what happens if you combine those? All right, so we're going to look at what happens when there's two of them and you put them in water. And the two effects will determine together the overall salt's identity. It does have to change the pH by more than like 0.5 or 0.5 units in a 1 molar solution, though. It does have to be a little bit significant. And if we can't come up with a nice ballpark, then we're going to have to do quantitative and we will have to compare Kas and Kbs. All right, so what kind of cations am I talking about? I'm talking about any of the transition metals and the molecular bases. They're going to all form slightly acidic solutions, okay? Except those that come from the six strongies. All right, so lithium, sodium, potassium, calcium, barium, and strontium. Okay, those cations, they will not react with water, so they're just going to be called spectators. They're going to be called spectators. All right, what about your anions? The conjugate bases of weak acids will form slightly basic solutions, except, okay, except the ones that come from the strong acids. All right, before I use this table, I'm going to go over and switch to the whiteboard. Okay, what kind of pH do we have? So let's say I dropped sodium chloride into some water. Okay, so I'm dissolving the solid sodium chloride. Yes, I know that's a dissociation, but I'm wondering what each of the pieces will do once we're in there. So I have the sodium ion and I have the chloride ion. My question is, will the ions react with water to change the pH? So we're going to do the equations first before we do the shortcut. So let's ask, hey, water, will you react with sodium ion? And the water says, well, I don't know. Do you want me to? And the only thing possible would be if the hydroxide combined with the sodium and then this proton just came flying off. Okay, that's possible. That could happen, but let's take a look at the reality of it. I just formed a strong base. Nature loves neutral or the lowest energy case, and then we can also add in there the weakest possibility, and in this case, base. So nature is not going to take a nice neutral ion like sodium and react with water to make a strong base. Okay. Nature is not going to make a stronger combination. So that's why we would call it a spectator, because it's just going to float around. Spectator. All right, well, let's take a look at the chlorine. Hey, chlorine, will you react with water? Well, the only thing possible would be to rip off that hydrogen. Oh, are you already seeing the problem? I just made a strong acid. And nature is not going to react from a weak possibility and make a strong possibility. So this one's also a spectator. And that is going to happen every time we use the cations from the six strong bases and the anions from the six strong acids. So those are just going to be spectators. So let's ask that question again. Hey, sodium chloride, when I dissolve you in water, will you change the pH? And the answer is that one is a spectator. That one is a spectator. So the answer is no. It'll dissolve, but it will not change the pH. All right, so let's look at this little table. All right, here is my salt. I have ammonium and I have iodide. All right, we have to ask what each piece will do. So the ammonium, did that come from one of my six strong bases? Okay, is it on that list? And the answer is no, so it will turn it acidic. The iodine, did it come from my strong acids? And I'll put those over here. Who am I missing? Nitric. All right, did that anion come from one of my six strongies? And the answer is yes. Okay, that came from a six strongy, so it's a um, spectator. So the cation's going to try and turn it acidic. The anion's not going to do anything. So the overall effect is going to be turning the acidic or the solution acidic. Okay, let's ask zinc nitrate. Hey, zinc, what are you going to do to the solution? All right, did that cation come from one of the six strong bases? And the answer is no, so it's going to turn it acidic. The nitrate, did you come from one of the six strong acids? And the answer is yes. So it's a spectator. And so the zinc's trying to turn it acidic. The nitrate is doing nothing. The overall solution will be acidic. All right. How about potassium perchlorate? Hey, potassium, did you come from one of the six strongies? Yes. Hey, perchlorate, did you come from one of the six strongies? Yes. So neither of them are trying to change the pH. They're just floating around and it will be neutral. How about sodium phosphate? Hey, sodium, are you going to try and turn water acidic? Are you going to try and react with it? Did you come from one of the six strong bases? Yes, I did. So no, it is a spectator. Hey, phosphate, are you going to try and react with water? And the answer is yes. That did not come from one of the six strongies. So when you make that combination in nature, it's a little weaker. So it's going to be trying to turn the solution basic. And so overall, that solution would be basic. All right, now that's a nice qualitative test, which most of the time, that's probably good enough. But what if they both come from weaks? How are you going to tell what the overall um, acidity is going to be? Well, now you have to compare numbers. All right, so up here, if the Ka, the overall Ka is greater than the Kb, it's going to be acidic. If the Ka is less than the Kb, it's going to be basic. And if for some reason you magically get them to be identical, it would be neutral. So let's take a look at this silver phosphate. Let's look at this silver phosphate. All right, Silver, what are you trying to do? Did you come from one of the six strongies? No, so I'm trying to turn it acidic. Hey, phosphate, what are you trying to do? I didn't come from one of the six strongies, so I'm trying to turn it basic. This is a competing effect, so we would look up the Ka and the Kb. And so what Ka are we talking about and what Kb are we talking about? So imagine that this is what I would made, and this is what I would have made. Okay, because that's the question I'm asking. Will you react with water to do that? And those are the Kas and the Kbs that I would compare. Again, can be done, but we're not going to focus on that very much, as long as you recognize what you would have to do in that kind of a case. All right. Jump one more time. All right, what is going to change the pH of water? All right, well, first, ionizable hydrogens. Okay, so basically your acids. Okay, the cations, other than from the six strong bases. Three, anything that contains hydroxides. So how do I want to write that? Salts with hydroxide or oxide dissolved in water is pretty much the same thing, okay? Because those are just bases. Ammonia is a molecular base. And so it will form ammonium hydroxide. And let's see, last but not least, the anions. Other than from the six strong acids. We'll turn it basic. Once you've realized what it's going to do, and what do I want to call this? Let's say A. You have to write a balanced equilibrium expression. So in order to do that, you have to have a balanced equation to write that expression. And then you can go on and figure out what the pH is. So B, if it is a strong acid or base, remember they're just 100%, so you can just take the negative log of whatever their concentration is. But, let me see what color I'm going to use today, C. But, if it is a weak acid or base, then you have to do the equilibrium concentrations. All right, and that ties together the weak acid and the weak base chapter. All right, till next time, jolly out.